Hi, I'm Larry Puckett, the DCC guy. You know, in previous videos, I've shown you a lot of things that you can do with these Tortoise switch machines. I've shown you how to pre-wire them. I've shown you how to fix broken ones. I've shown you how to wire them up and control them using a switch 8 and the control panels that I use here on the Piedmont Southern layout. One thing that I haven't shown you to do, though, is a few little tricks that you can do to use the internal contacts, because these are made with two single-pole double-throw switches built into them. And every time that you throw the switch machine to throw your points on your turnouts, it changes these internal switches. And you can use that to your advantage for a number of different purposes, what I call my tricks with tortoises. So let's go ahead and get started. Okay, before we get started, I want to ask you to take a second to subscribe. Click on the subscribe box, and when that comes up, click on the little bell right next to it and click all. Now, some of the things that I'm going to be showing you today are going to come out of my books, Wiring Your Model Railroad and Wiring Projects for Your Model Railroad. So if you don't have a copy of these, you can get them. They're available through Combat Books. You can get them from Amazon. And if you go to the Barnes & Noble bookstore, you can actually purchase them through Barnes & Noble and get the electronic digital form that you can read on your computer, your iPad, whatever. And I have at least one of these in digital. I keep this one in digital form because it's a good reference that I use for my own purposes, because I don't remember everything that I put in these books. There's just so much in here, I can't keep track of it all. So consider purchasing these, particularly this one here, if you're just getting into wiring your model railroad. And for some of the projects I'm going to be talking about, this is a very good reference. It goes into detail. I think there's like 17 or more individual wiring projects in this book that you can try out on your model railroad. So that's just a plug for my books. As I said, one of the things that we're going to be taking a look at is how to use the internal switches that are built into the Tortoise switch machines. And what I want to do is refer to this diagram right here. It's in the Tortoise instruction sheet, and it's figure 2, I believe, and it contains the settings for the various contacts on the circuit board at the bottom of the Tortoise switch machine. And as you can see, it shows you the positions for the two single-pole double-throw switches that are built in. So you need to refer to this when you're setting up some of these tricks with tortoises that I'm going to show you. Got the paperwork out of the way, so let's take a look at some of the things that I can show you how to do. You know, previously I showed you how to pre-wire these. And in that case, I showed you that, I wire up my black and white wires to control the motor, and then I go ahead and pre-wire the 3 wires to that first of the single-pole double-throw switches built in here. And the reason I do that is because I use that invariably just about everywhere to control the polarity of my frog. Because one thing that you can do is you can take the red and the green wire, and I use these as the colors for my main power buses. And you can attach these to your main power buses, the red and the green wires, and then attach the yellow wire, as I've shown you in the past, to the dropper or feeder that goes to the frog on your turnouts. And I've shown you that with both the Pico and with my micro engineering turnouts. I pre-wire these and put on a feeder that I can use. And all you have to do then is connect these 2 wires again, the red and the green, to your power bus, and then connect the yellow wire to your frog. And then every time that the tortoise is cycled, it will automatically change the polarity of your metal frogs. Now this, of course, only works with metal frogs. If you've got Insul frog turnouts that have plastic frogs, or any other kind of turnouts that have plastic frogs, it won't work because they're plastic. You can't solder to plastic, okay? But at least with the turnouts like Atlas and Microengineering and Pico and Walthers, you can connect your tortoise switch machine directly to your frog feeder and control the polarity that way. So if you're using tortoise switch machines and you're not doing that, then that's a great way to implement the first trick. And I'll show you that over here on the layout in just a minute. Now, another thing you can do, and I'm going to show you this example, the wiring, before we get started. Now what I've done here is, in addition to those first 3 wires that I showed you, I went ahead and added this red and blue wire to the second single pole double throw contacts that are built into the Tortoise switch machine. Now why did I do that? Well, as I'll show you in a minute, there's another trick that you can use to go along with your frog polarity setup here. So let's go ahead and move over to the layout, and I'll go ahead and start showing you how I use these various other contacts. Oh, before we move on though, let me point out one thing that I find very, very useful are these test leads. They have alligator clips at each end. They're about 8 inches, 9 inches long, something like that. I buy them by the bundle from allelectronics.com, and they're great because they allow you to make some quick test connections before you do your final soldering or before you use suitcase connectors to make a final connection. And these are great because this way you can check to see if you need to reverse any set of wires because you've got the polarity backwards. So let's go ahead, and I'll talk some more about this as we go through this little project. Now, one of the first things I want to go ahead and show you is how I used that second set of switch contacts with just the 2 wires hooked up to the single pole double throw switch. Now you'll notice I've got a bunch of LEDs here, but the ones that are important in this case are these LEDs right here. Each one of these is actually a push button with an LED built in. So let's say that I want to throw the switch so that a train can come up the ladder and go to position or track 2. This is the northbound switching track. So if I hit that, it's going to change the position of that turnout, and I've got that turnout set, or I've got the Tortoise wired so that a wire goes from a 2-volt power supply off of my main 12-volt bus and powers this LED and turns it on. Now, if I wanted to go to track 6, it's going to come on, and you notice that track 2 went out. That's because this Tortoise was realigned to straight through. And each one of these is set up that way. So I can switch the lead to my scale track or my pulp yard lead. And this particular switch machine here, the Tortoise, is actually controlling the power feeds to these 2 separate LEDs in the push buttons so that I can always know when I have the proper turnout set for that given track in the yard. And because I've got this set up through a Digitrax DS64 programmable accessory decoder, it will actually throw every turnout up the ladder so that I only have to push one button in order to get the entire ladder oriented or set up for a train to come all the way up to track 6. And again, the LED that is built in here, this little green LED, is powered and controlled by the single pole double throw switch built into the Tortoise switch machine. And for that, I only used 2 of the 3 positions for that second single pole double throw switch, because the first one is controlling the polarity of the frog here, and so the second one is controlling power to this LED. And that works very well. I've really liked that because it allows me to know specifically when a route that I want is actually set up, because this light does not come on until that particular turnout and this one here have been thrown to allow trains to access this track. And the way that I wired that, I simply used again, this red and the blue wire. So I'm only using 2 out of the 3 contacts here for this single pole double throw switch. And so this one goes to the power lead from the 2-volt power supply. And if you remember in the past, I showed you how to use the voltage dropping buckboards in order to create a sub bus. So I've got a 12-volt DC power bus under the layout, but then I created a 2-volt sub bus just to power these LEDs, okay? Because a green LED runs at around 2 volts. And then this is attached to the power going to that 2-volt power supply, and this one then goes to one of the leads on the LED, and then the other lead is directly wired to it. And that's where you have to know your polarities, and where having a clip lead, like I just showed you, can be very important, because you can clip this end of this wire here to a clip lead and hook the other end of the clip lead to one of the contacts on your LED. And if it doesn't work, then you switch it to the other LED contact, and then if it comes on, you've got it right. And then you can make the final solder connection. So that's where those clip leads can be so useful, because they allow you to test which polarity is correct. So that's how I use the second one. So let's look at this first one. Now again, as I said, I take my red and my green wires, hook them to my power bus, and then run this up to my frog. So let me show you that here on the turnout. So what I have here is, this is one of my microengineering turnouts, and I do have power supplied by the Tortoise switches to this given frog here. So this frog is powered by the single pole double throw switch in the Tortoise switch machine that controls this set of points. So now I've got it set for diverging to go ahead and cross over, because it's part of a crossover. And let's go ahead and run a locomotive through it, and you can see that the locomotive is going to go right on through those set of points without any problem. Okay, and we can reverse that and come on back through. I've got the sound turned off. Now let me go ahead, and I've thrown that set of points, so it's now set to go straight through. So let's watch and see how it does. You can see the locomotive is going to go right on through those points and then through the frog without any problems at all, because I've set the polarity using the Tortoise switch machine single pole double throw switch. Okay, so we've got that taken care of. Now another situation that I have here, created by this by the ladder here in the yard that I just showed you a minute ago, I have this one turnout here that is on the arrival and departure track, or what's called the northbound passing track. And what happens here is, as long as it's set straight through like it is now, then there's no problem. Okay, my locomotive can go through without any issues whatsoever. The problem arises, though, when somebody has been doing some switching here in the yard, and they have set the ladder so that trains can actually move up the ladder from left on, go up the diverging leg of that turnout. So when I throw that switch to go up the ladder, then this diverging leg of the turnout is set against this particular locomotive. It can't go through, but it'll try if I'm not paying attention to what I'm doing. So what would happen, and let me point out here, because I was already going to be using both of the daggone single pole double throw switches for this given Tortoise, I went ahead and used a frog juicer here, because there's only two sets of contacts, or two sets of switches built into the Tortoise. So I'm using one of them to control the LED in the push button that goes with this given turnout, and then I'm using the other for another purpose. So I didn't have it available to control the frog polarity here. Consequently, I went ahead and used a frog juicer. So I can run a locomotive right through there, and it'll go on the ground and cause a short that way, but it will not cause a polarity short here because I've got the frog juicer. So that creates a problem, because if I'm working up in here, I very often forget that I've left this turnout thrown against mainline traffic here. So what I did was I took that second single pole double throw switch that I showed you was wired with a red and a blue wire. And what I did was I hooked the red wire to the red power bus, and then I ran the blue wire up and connected it to this track right through here. And then I made a cut right here with my Dremel tool, and I made another one back up here. Let me see where it is. Ah, it's right here. So small you can barely see it. So I've isolated this section of track. It's a little over a foot long or so. And watch what happens when a locomotive enters that isolated section of track. It's going to stop dead. The reason being, I wired that up so that when the switch is set against the locomotive, then the single pole double throw switch that is wired with just the red and the blue wires cuts power to this rail over here. Consequently, this locomotive will not move any further than this, and that prevents it from running through and derailing at the points and causing a short circuit that way. So let me show you what happens if I go ahead and I hit the push button control for my north passing, and you'll see when it comes up green, that locomotive takes off because he now has power back on that track. I should have gone ahead and turned the power off to show you that. But he can come back through there. And again, I'll show you this whole sequence one more time. So I'm going to throw the switch against him. So it's set to go up the ladder. And we'll watch what happens when that locomotive enters. It will come on in here. And as soon as it crosses that gap onto the isolated track, it's going to stop. And you only need to isolate one of the tracks and power feed it. Okay, now I'm going to turn the power down. I'm going to cycle the switch so that I've got power going to that track again, and then I can turn it on, and it'll just go right on by. That prevents those crazy derailments that are constantly bugging me anyway, because I am constantly moving locomotives up into the yard, forgetting that I set this switch to go up the ladder, and then I'll bring another locomotive up, and bingo, I've got a derailment there. Of course, the other problem is, what if you have more than one locomotive in a consist? Well, there's a good chance that that second locomotive is going to keep pushing this guy further down. And that's why I made this a fairly long section, because by the time that he starts pushing, the second locomotive starts pushing the first one, the driver, the engineer, is going to recognize that he's got an issue and that he needs to go ahead and make a change to his throttle setting and stop that locomotive. Okay, now what we have here is a section where we've got the C&O tracks right here, and they cross the Southern Main Line here in Charlottesville, Virginia. The CSX tracks still are there crossing the Norfolk Southern Main Line, and it's been going on for a long time. But in order to protect the main line trains and the C&O trains, there was a semaphore set up there for many years. It's now, standard incandescent or LED lights probably. But at any rate, I wanted to be able to set up a semaphore here to protect the main line and tell those C&O crews to stop at this point and wait for a clearance. So right here we've got the tower next to the passenger station, and what I can do is I've got a double throw switch here on the fascia, and I can throw that, and a Tortoise switch machine controls the semaphore that is built into this mast here, to this signal. The LED here in this Tomar signal light is always on. So all we are doing is moving the semaphore itself, and the different lenses are lined up. So you can set this up for a red, a yellow, or a green indication here. And it simply involves throwing a switch, and then the mechanism is something that is sold by Circuitron. And I'll show you a photograph here in a minute underneath of the layout of how that is set up and how it works. But this is physically controlled and activated by a Tortoise switch machine. And I'll show you here, I can come in and zoom out just a little bit. And you can see right here the toggle on the front of the fascia that controls the position of that semaphore and gives you a red to tell those C&O guys to stop, or once they've come to a stop and the tower has decided that they are safe to go through, you can give them a green light and they can go on through. And then there's a center off position that I use just to kill power, because the signal will stay in place without having the motor powered all the time. So it takes a little bit of the tension off of that. This was one of the projects in my wiring projects book, and show you how to go through this step by step and wire it and install it. And it's a fairly easy project, and you could use this, throughout your layout. You could have controls running from your control panels back to to semaphores and signals throughout your layout to control the movement of trains by a schedule. Here you can see the two wires coming from the toggle switch that I just showed you, and that just controls the direction of the motor. And this device here, this large black rectangle, is the control mechanism that transmits power from the Tortoise switch machine to the up and down arm control for that Tomar semaphore. So it's just this small fine wire here that runs over to another one, and I'll show you that in a second, that gives you the up and down motion. So let's take a look at that. All right, here, this is the other end of that thin wire that I showed you coming out of the Tortoise switch machine mechanism there. And that, in turn, controls this arm here and pushes this thin wire up and down. And this is the wire that goes up to that Tomar semaphore and makes the blade change position, either up or down. And in turn controls the color of the lights in the semaphore itself. So these two fine wires right here are the wires that go up to that LED. Okay, what I want to show you now is the last of them. We have a standard railroad crossing here, and this came out of off the cover of my book, Wiring Projects for Your Model Railroad. And this was one of the projects among those. And let me go ahead and bring a train around, and you'll see what happens as he approaches Charlottesville. Okay, he has just gone across the photocells, or the photo detectors, and tripped the circuit that closes the gates here and starts the lights going and the bell ringing. And I can run him right on through here, and he's not going to, that bell is not going to stop, and those lights won't stop, and those gates won't go up until the train has passed through a set of detectors on the other side of the crossing. Okay, he's just crossed it, and the gates go up, the lights go off, and the bell stops. And I can run this backwards, and because of the circuit design, it will not trip going the reverse direction. You can set it up so that it will. I decided not to. And again, this is one of the projects in my book, Wiring Projects for Your Model Railroad. And I'll show you the actual circuit here in just a minute. Let me get the locomotive back through here and out of the way. And again, the crossing gates are activated, controlled by a Tortoise switch machine using pretty much the same mechanism as I used for controlling that semaphore that I showed you, protecting the crossing at Charlottesville. So let's go ahead and take a look at the circuits in my book, Wiring Projects for Your Model Railroad, for this particular project. Now this is the control circuit for the crossing gate project. You can see here it came pre-built for an extra charge. He will put it together for you, and I went ahead and did that because it's a little complex project, and that way it's guaranteed to work. Whereas if I put it together, you never can be sure. At any rate, it's a fairly straightforward thing to go ahead and implement. You do have to install some photodetectors between the ties. And interestingly, they work very, very well, even in the low light setting on my Piedmont Southern section. And this is this bell I got from eBay, I believe it was. It could have been Amazon. I'm not sure. And it's just your standard old-fashioned doorbell with the little ringer here. And that connects directly to this connection right here on the circuit board. So it's a very well thought out circuit. And I will put the URL for Rob Paisley's website in the description for this video, so you can go there and take a look at the kits he offers, because he has lots of different kits for all kinds of different projects. And as I say, you can buy this as a kit, or you can buy just the bare circuit board, or he will pre-build this for you for a very reasonable price. Let me tell you, it's worth it to have him build it for you. Well, that's a wrap for today's video. Go ahead and try some of these projects. The ones with the Tortoise switch machines to control your frog and other little electronic things like that, dealing with your turnouts and track, are very easy to do. It's a simple matter. These projects where you use the Tortoise to control something like this semaphore, or to control the crossing gates, they're a little bit more complicated, a little bit more involved. But the great thing is, I've already written up the procedure for you. All you have to do is follow the steps that I lay out in the articles. So that's about it for today. Have a good weekend, and we'll see you here on Monday with another video from the DCC Guy. Bye now.